But thank you all for joining today for the workshop on pathways to efficient industrial electrification. As I mentioned to the people who did join early, as people are just joining the room, I'd love to hear what you think of when you hear the word electrification in an industrial context. So if you could go to menti.com, enter the code on the screen, either in your phone or on your computer browser. There's a link in the chat that Evan pasted in there. And I'm just going to give a minute for people to respond to that question. So I'm Jay Mullen, one of the energy management coaches with the Save on Energy program, and I'm excited for today's workshop. All right, let's see what some of the answers coming in here. Decarbonization, renewable energy, low carbon, complex. Yes, it is quite complex, and we're going to be getting through some of that today. Expensive, it can be. Although we have some interesting case studies that have come up where it's not always that expensive in there. Power source, fuel switching, excellent. All right. Now, for those of you just joining, there's a link in the chat to the Menti question, or you can follow the instructions at the top of the screen. And please keep this open in a browser as we go through today's workshop, because we will be returning to the questions on here. So you can have it on your phone or in a browser on your computer, but please leave that open as we go through today's workshop. All right. So welcome, everyone. And this workshop, we're going to be looking at industrial electrification, specifically related to heating. So I know there's a lot of other things going on, forklifts and stuff like that. We're specifically going to be looking at industrial heating. And we're going to start looking at some different heating applications, available technologies, and their feasibility. And then we're going to look at helping you identify some next steps to strengthen your electrification plans and how you develop those strategies and strong plans to achieve electrification goals, even if, at the moment there may be some barriers for certain aspects of it, whether those be financial or available technologies, that sort of stuff. So hopefully this will help give some clarity of how to plan for that long-term electrification of your industrial processes. We do have a participant workbook to follow along in. So Evan's going to drop a link in the chat for you there. And if you can open that link, it is read-only, so please save a copy to your computer, and it'll both follow along, summarize the content we're looking at, but it'll also have places to take notes to help you relate what we're talking about to your own processes and to your own facilities. So please download that workbook and save a copy onto your computer to follow along and fill out as we go. Also, this will be an interactive workshop. We do have a short breakout room and a longer one later on to work through some of the material. And I do encourage any questions. If you have any questions as we go, please drop them in the chat. And I'll be keeping an eye on that. All right. So what's driving decarbonization? So I think that's a good place to start for this. Why is industrial electrification important, and what's driving it? So Canada as a country, we do have a net zero GHG emission goal by 2050, and industrial emissions, excluding oil and gas, account for 11% of Canada's emissions and 37% of Ontario's emissions. So that's a pretty big chunk. And when it comes to economic pressures, there's drivers around carbon pricing, utility costs. Even with the recent canceling of the carbon tax, there's uncertainty as what will replace it for industrial emitters or what future carbon costs might be. For companies that export, there's also the potential for border adjustment mechanisms like what the EU is starting to implement. And manufacturers are also facing pressure from their customers who are working to decarbonize their supply chains. Now, within those overall decarbonization efforts of that scope, electrification is going to play an important role in achieving those outcomes required by the drivers that I just mentioned. The U.S. Department of Energy, they have an industrial decarbonization roadmap, and they categorize decarbonization strategies into 5 pillars: energy efficiency, material efficiency, low carbon fuels, carbon capture, and electrification. And while these will likely all play some role, today we're focusing on that electrification piece. And why electrification is such an important part of it is that, first of all, it allows the elimination of on-site combustion and the associated Scope 1 emissions. And it can also provide additional co-benefits, which we're going to be exploring through today's workshop. In addition, comparing to those other five things, efficiency is a great one, but that alone isn't going to be enough to achieve the results that we're looking for in terms of those long-term goals, even though there is significant opportunity to improve efficiency and reduce fossil fuel consumption through that. Those low carbon fuels, carbon capture, again, they have their applications, but it's looking like those are going to be quite costly. And so achieving long-term GHG reduction goals is unlikely to happen without electrification of at least some key processes. So we're going to go back to the Menti now, and I want to get your thoughts on what do you think is the biggest barrier to industrial electrification? If you go back there, Evan's going to drop that link in the chat again for the people who just recently joined, or you can follow the instructions at the top of the screen. But what do you believe is the biggest barrier to industrial electrification? All right. It takes a little minute because you have to put all of them in order, but we're starting to get some responses in now. Okay, so we'll give a minute to see what this is looking at. And if anyone's looking at those, if you've already put in your answer, but there's some barrier that you see that you think is like one of the big ones that might not be on this list, drop it in the chat because I'd like to hear that if there's anything on this list that you think is right. Yeah, cost of electricity itself. Yeah, Kareem? And the cost of electricity, so there's a term that might come up through this workshop a little bit called the spark gap. And what the spark gap is, it's the ratio of the unit cost of electrical energy compared to natural gas. So how much does a joule of electricity cost relative to a joule from natural gas? So that spark gap, it's typically 4 to 8, depending on what jurisdiction you're in. There's a lot of things like your rate structure, the market cost of natural gas, like how that demand is, that goes up and down. A lot of things can influence that spark gap, if there's a carbon tax on there. But it is a big driver, as you mentioned on there. And we do see in jurisdictions where that spark gap is like 3 or 4 or lower, more electrification happens because the efficiency benefits and other benefits of electrification are enough to be offsetting that increased per unit energy cost of electricity. Okay. All right, so yeah, the high costs, electrical infrastructure limitations are common ones there. So there are some key barriers that are slowing or preventing progress in electrification, and it is important to understand those. And depending on the organization and location, we see some point to a lack of technology or a lack of awareness, or sometimes even misconceptions about what technologies are available as the primary barriers. And for others, we see them citing like infrastructure constraints or the lack of return on investment as key barriers. But progress is happening. So, 3M has committed to net zero GHG emissions by 2050, targeting a significant reduction in Scope 1 and 2 emissions by 2030. The driver of this isn't just about carbon, it's also about safety, better process control, responding to investor, environmental, social governance expectations. They do have a carbon pricing mechanism that helps make the financial case for these projects. And they have recognized that efficiency improvements alone won't get them to net zero, that electrification is essential, and they are pursuing that. Another example, Cascades. They've set a goal to reduce Scope 1 and 2 emissions by almost 40% by 2030, and their actions include redesigns of processes to reduce heat demand, as well as shifting from fossil fuel to electric heating and drying systems. So that plan's supported by provincial electrification incentives, and really highlights the importance of understanding local funding programs and policy support. So we have a lot through Save on Energy as well. And Ontario, not quite as green as Quebec, BC, but still low enough emission grid that it is a significant driver of carbon reductions. And lastly, we have AMD from Hamilton, again, committed to significant GHG reductions, and the bulk of those reductions are coming through a major shift of replacing coal-based blast furnaces with electric arc furnaces. This transition alone is expected to cut 3 million tons of CO2 per year. I'm just asking if you're happy to take questions, but please mute yourself if you aren't sharing right now. And Evan, maybe if you can mute people as they're coming in. Drivers for this are, customer demand for clean steel, but as well as potential export constraints and opportunities. So we mentioned those border adjustment mechanisms, and the EU is planning to start imposing a carbon levy on steel imports in 2026. So that can open up opportunities if you have cleaner production steel, or it can be a penalty if you don't. So it's important to note that this is expensive, high upfront costs that we highlighted in there in the question that we had, and it is receiving some federal support as well. So if those are the barriers, but organizations, companies are still moving forward anyways, we need to understand what are some of those available technologies. And one of the big drivers of what technologies are available is driven by the temperature. What temperatures are required for your processes? So that plays a lot in terms of determining the feasibility, with electrification being most feasible in those low to medium temperatures. So on the lower temperatures, less than 100 Celsius up to 300, common processes like space heating, washing, pasteurization, things like that. We start moving up 300 to 800. Common processes include food processing, paint curing. We start getting into the high temperatures, looking at metal treatment, glass, ceramic production, very high temperatures around greater than 2000 Celsius. This is like niche stuff like growing silicon crystals and testing, space shuttle materials and things like that. So what we're going to do is, this is going to be our first breakout room. It is just going to be a short one, so we're going to give you about 7-8 minutes in your groups. But just to kind of set the stage, I want to give you a chance to, discuss what those fuel-based heat sources are and what temperature range do they fall into, and how much of that is using your fossil fuels at your site. So if you go to page 6 in your participant workbook, there's some place to take down some of these notes and start making your own kind of inventory on there. But I'd also like you to share with each other around what are the heat processes that you have in your industrial facilities and what does that temperature range look like, so we can get a sense from each other of what we're dealing with at this time. Is there anything that I can clarify, or does anyone have any questions before we launch the breakout room? Okay. Evan's going to launch those. Again, this one's going to be a short room, just to really quickly talk about, what are those heat sources, the temperature ranges that you have, and then we'll meet you back here to continue. All right, so Evan, if you could launch those. All right. So welcome back, everyone, from the breakout room. I know it's just a short one, but I'm curious to hear, in your breakout rooms, what were the types of heat applications, the types of temperature ranges that are being used in your facilities? Does anyone want to share what they heard in their breakout room? Who could be a brave volunteer to go first? In the main room, we were talking about, some space heating, some processing, pasteurization, which is on that lower end of that scale. Did anyone have any does anyone have any of those higher temperature range applications within your facilities, or that you heard about in the breakout rooms? Okay, I see it in the chat. AEC industry, temperatures on the low temps. Okay. All right. So I think it's like a really important place to start is understanding what are those heat applications within your facility, what temperature ranges are required, what is the nature of that. And because when finding those alternatives to fossil fuel heating, it's important to understand what technologies might be appropriate, which might be on the horizon. And there's a lot of things that are available, and depending on that range and that type of application. So as I go through this section, I want you to think about your own facility processes, which technologies might be appropriate. Temperature isn't the only consideration. So you have to consider the nature of the process. There was some discussion in the chat about, furnaces for blast furnaces for iron steel production, and how the fossil fuels play a role not just in heat, but in providing hydrogen for the chemical reaction as part of that. So you want to think about things like that. So there's some electric heating, electric resistance, induction heat that can be used in, installed within a range of equipment within different processes. Heat pumps, electric boilers, thermal batteries, they give kind of general heat, but they do require that specific equipment type to be installed. And there's niche applications like dielectric, infrared heating, lasers, electron beams, things like that. And they all have these different applications. So they can be used in a variety of areas. Some of them are fairly well advanced when it comes to their technology readiness level, which is that TRL on the right. And within that, basically, like anything from an 8 to 11 is, it has at least some commercial applications in place. So, there's electric boilers, easy to install, integrate, low efficiency relative to heat pumps, high operating costs as a result of that. Resistance heating is, existing operations, some applications, about the same efficiency, but limited power density, similar operating cost barriers to that. Induction heating can get high temperatures, high capacity, high efficiency because you're only putting heat where it's needed. This is already can be cost competitive, have a good ROI in some applications, but it is restricted to conductive materials and sometimes limited by geometry. So it's not necessarily great if you have a lot of different parts or shapes of things that have to go through that process. We get into some of these other things like plasma torches, high temperatures, but also very high operating costs, arc furnaces, high temperature, high capacity. They're proven. As was mentioned, you may still need to deal with the chemistry side of things in these situations, depending on what you're using them for. It also doesn't entirely eliminate emissions because there's consumption of graphite electrodes as part of that. Thermal batteries are starting to become available and starting to be demonstrated, and those can help manage some of those electricity time of use costs, the demand costs that go associated that can drive increased operating costs. The downsides are the capital costs of them, space requirements. We have dielectric heating, which can be good for some systems like cooking, drying, where water evaporates and can escape the system, but not as broadly applicable as things like heat pumps. Infrared, another one where there are applications today where that makes a lot of sense, and using EM radiation instead of convection has some of the benefits of that: fast response time, focused heating areas, and we get into some of these high cost, very specific ones like the laser heating, electron beams, things like that. When we start looking at industrial heat pumps, and their readiness depends on the temperature that you're looking at. And we see that, we have some demonstrated commercial applications for temperatures up to about 140 C. Higher temperatures are a bit earlier in development. There are steam generating heat pumps that are commercially available, but keep in mind that this chart here is from the International Energy Association, which takes a global view. So some of these technologies may be available commercially in Europe, but might face practical challenges getting them here in North America, like finding a supplier or train maintenance, getting parts can be a real headache. So they may not be practical in this situation. But yeah, so it's important to see like where you are now, and depending on that temperature range that you're looking for? Is there technology that's currently available? Is it on the horizon? Alan makes a good point for the infrared heating to watch out for product deformation because of close proximity. If you need the spacing, it can be. I have seen applications where it improves quality, but yeah, do need to be careful and deal with the quality control on that. And one example here is a bakery that transitioned from natural gas ovens to infrared ovens for bread baking. And this led to 30% reduction in energy consumption, improve the baking consistency, reduce the warm-up time, so better quality, higher throughput, enabled precise zoning, modular control, reducing the waste during startup and shutdown. And what's important about this example is that replacing the natural gas oven with an infrared oven wasn't just about, the efficiency of the heating or about reducing the GHG emissions, but it also delivered process improvements in terms of that product quality, production throughput. And in this situation, those benefits were really important when making the case for electrification, because that can help in those situations when the ROI based just on that spark gap, that ratio of cost of electricity to natural gas. It's not going to make the business case in that. That's going to increase operating costs. But when you look at these other benefits that are coming into play, that can sort of tip the scales depending on what is your process and what are those opportunities. Which brings us to another point about what about those applications where the appropriate technology is not currently available or feasible. We had some great comments in the room with Karim talking about how, sometimes an electrification project that makes sense in BC or in Manitoba or some other jurisdiction might not make sense in Ontario or somewhere else because of differences in those electricity projects. So, sometimes you have an application where the technology is not available. Sometimes the technology is available, but it's not necessarily feasible for some reason. So one opportunity, depending on your situation, where if you're in that situation where they aren't necessarily feasible, there can be opportunities to rethink the process design and how that process is used and uses heat. Because many industrial processes were designed around the characteristics of fossil fuels and how they are used in heating. So simply replacing a gas burner with an electric heater might not be technically feasible or cost effective or operationally viable, but there might be opportunities to rethink the processes with electric heating in mind. So we have 5 strategies of process changes that can help facilitate or help enable electrification where that direct substitution just doesn't make sense at the moment. And as I go through these 5, I want you to think about which of them might be appropriate for any of your processes. So the first one is low temperature alternatives. So this is where you adjust your process so that it still works effectively at a lower temperature that might be more feasible to provide through electricity. So there's a lot of processes where it's a balance between temperature and time. You can have it hot for a short period of time or not so hot for a longer period of time, like pasteurization, where you can extend the time that it's held at a lower temperature and get the same results. This can help enable the use of heat pumps or other processes that are feasible at lower temperatures, but maybe not at those higher temperatures. It can increase cycle time. You do need to still verify the quality verification studies. And another thing on the lower temperature alternatives is in some cases, it's useful not just to think about the absolute temperature, but also the rate of temperature change. So there was a project by Volvo in the US where they replaced a heat treatment furnace with an electric option. But one of the big challenges with that was the impact of demand charges, and not so much when the furnace was operating. It was a 1700 Fahrenheit furnace. Holding it at that temperature wasn't that big of an issue, but getting it up to that temperature would have caused a lot of additional costs in terms of demand charges if that was electrified. So when going to the electric furnace, they extended their ramp up time. So with a natural gas furnace, they would ramp up over 2 to 3 hours. They adjusted their processes so that with the electric furnace, it would ramp up over 24 hours. Now, this furnace is usually running 24/7, so there isn't a lot of ramp up, ramp down, but changing that process, the rate of speed, helped facilitate or enable the electrification. Another option is mechanical substitution, so replacing thermal processes with mechanical ones that use less heat energy or no heat energy at all. So one example could be mechanical pressing or a centrifuge instead of thermal drying, and this can dramatically reduce the heat energy demand and can be electrified with motors, drives, might require equipment redesign, handling modifications. It also might not fully eliminate the need for heat, but can reduce how much is needed to reduce the impact on those operating costs related to heating. There's also non-thermal or chemical alternatives. So, using UV, microwave, radio frequencies, chemical processes instead of heat. So an example of this is using paints that are UV cured instead of heat cured, or coatings in that way. So these can have high efficiency, fast throughput, lower temperature requirements, often good quality outcomes as a result of this. But it can, again, it has to fit in with the compatibility of the other aspects of the process, like applying those coatings. Worker safety, exposure needs to be addressed. If there's UV light, strong UV lights, things like that, there's safety considerations as part of that. Another option is to switch to modular or batch operations. So replacing a large centralized system or like a continuous system with multiple smaller electric units, or transition from continuous to batch. Example is replacing one large boiler. Again, another example from Volvo, they were looking at replacing 2 natural gas boilers with electric boilers. And again, would have increased operating costs by $500,000 a year, demand charges by $300,000. But in looking at their heating demand, they noticed that engine oil heaters were on that boiler loop. They didn't take a lot of heat, but they had a high temperature requirement. So taking those off of the boiler loop and supplying those with heat through like a tankless hot water system allowed the boiler loop set point to be reduced from about 84 C down to 71 C, which significantly increased the feasibility of electric heat option replacing the natural gas boiler. So, and this can also work with the chemical processes, moving from continuous to a batch process. There was, I forget the company, but they did iron processing. They moved from continuous flow coke-fired cupola to an induction furnace, but doing so required a batch process for the induction furnace. So they had to sort of rethink their processes in that. It also had different requirements in terms of quality of the raw material being used, but they did have a lot higher like material capture as part of that. So, it made sense economically from that point of view. The other option is a hybrid or transitional system. So, a phased blended approach allows for partial electrification or future conversion. So, dual fuel systems, electric preheating, oversized electrical infrastructure. If you're doing upgrades, thinking about oversizing the electrical infrastructure to facilitate future transitions. And this can provide a lot of flexibility to decarbonize gradually. And one example of this I saw was there was another, like a high temperature heat treatment furnace. One option would be to use one from Volvo, where they're talking about it's like that startup is really challenging. So, they could use hydrogen or gas for the startup, electric to maintain the heat temperature on there. I've also seen ones where they had a large boiler that was coming to end of life. They weren't ready to electrify yet. It didn't make sense economically, but they replaced that one large boiler with 2 smaller boilers with high turndown ratios. So improved the efficiency significantly, but it also helped future-proof future plans because, electric, like a heat pump or something in the future could replace one of those boilers or be added onto it, and with a high turn down efficiency, it could adapt and be flexible for future options as well. So I want you to choose 1 or 2 of your processes where you think electrification might be a challenge, or maybe you've already been looking into it and it's not quite working out. And think about whether any of these might be able to change the process to help accommodate electrification of the heating on there. So, thinking about, can the process operate at a lower temperature? Can the function be replaced with mechanical processes, chemical, non-thermal, any of those ones, if it can be broken down, hybridized? Does anyone have applications at their site that they have taken one of these approaches to facilitate electrification, or where this might be an option? And please raise your hand, come off mute, or you could type directly into chat. But I'd love to hear if there's any applications at your facilities where this could potentially be an option.
So Jay, it's Al Sutton at Toyota. We had a application of mastic as a sealant, so a sealing line that was natural gas fire tempered, and to aid in the drying of the mastic. We chose to take a look at infrared heating, and the comment that I put in the chat was a result of this initiative. We have since reverted back to the natural gas-fired booth. We just couldn't control the variation in substrate deformation to meet our quality standards.
Mm. Yeah, I think that's an interesting point too, because I've seen some case studies where that control or the focused heat that infrared can provide does provide benefits to the processes and can help with the quality
Absolutely.
control. But
Yeah.
I could see, like in your situation and other ones, where because it is a more focused heat, in some applications it might provide like an uneven heating that could cause issues. Does anyone else have any examples or potential areas within their facilities where some of these process changes might help out?
So Jay, it's Alan again. As part of our paint processes, we have a number of dip tanks to wash off weld flash or oils and that kind of thing. These baths are currently heated with natural gas-fired heaters and heat exchangers. We are investigating the use of heat pumps for that application, but at this stage, it's just drawing board and estimates. We haven't moved forward on a project yet.
Mm-hmm. Okay, that's an interesting one. And yeah, so I think I'm going to keep going, but if you have any thoughts about this for your facility, you can write them down on page 11 to keep notes on that. But I think one of the things, and Alan, you pointed this in your examples, is that rethinking production changes. It can be challenging. So it's not something that can be done quickly or easily or without research, redesign work, waiting for the right time when maybe that production line needs to be revamped anyways. So there's a lot of challenges that come along with that, the quality testing, et cetera. So it's really important to think about these electrification efforts and how do you focus on, what should be focused on at different times, because they're going to have different timelines and complexity. Not all these opportunities require that same level of engineering, validation, or even capital investment. You need to know how to allocate your resources. So focusing your limited budgets, labor, the electrical capacity that you do have on the right projects at the right time, and demonstrating that early success, those quick wins that build momentum and showcase tangible results, help secure more buy-in. So in the short term, particularly as we talked about before, in jurisdictions like Ontario, where maybe that spark gap is higher than others, it often makes sense to focus on optimization and efficiency improvements in the short term to reduce that heating load. Those often have good ROIs, and it'll help prepare those systems to be electrified more efficiently in the future because it's not as high of a heat demand or a heat load. And this includes looking at options for heat recovery in your facility for preheating or for other applications like that. So there might also be applications where electrification does make sense, where, for instance, steam tracing, replacing that with electric tracing to heat pipes, or applications that have those production benefits to provide value beyond just or to offset that increased utility cost that comes along with it. So in the short term, focusing on those. In the medium term, thinking about things like end of life upgrades, planning for those process changes or infrastructure upgrades that are going to facilitate electrification of those trickier applications. And a key thing here is avoiding stranded assets. So prioritizing with that lens can really help you avoid situations where you're locking into long-term high carbon, high GHG emission situations. So, if a boiler is coming to end of life or a production line is being replaced, in the medium term, if it doesn't make sense, maybe to replace it, maybe the incremental cost makes sense in that, or at least thinking about how that can be replaced in a way that is going to be flexible moving forward, so that that long term, that it's going to be feasible with your long-term plans, and that your long-term plans aren't kind of being sacrificed for those short-term drivers that you're facing today. So this can be things like, hey, if you're doing an expansion, a building upgrade, putting in the electrical infrastructure that will accommodate electrification when it does happen, so you don't have to upgrade that down the line, or looking at installing hybrid systems or systems with flexibility to help facilitate that, not necessarily like for like that now you're stuck with a natural gas boiler for the next 20, 25 years. That might impact your long-term goals. So that's really important in the medium term. When we start looking long-term and those plans, that's when you're looking to tackle the process changes, waiting for new technologies like the higher temperature steam heat pumps to become available, potentially for policies or new rate structures to come in place to facilitate some of these projects. And a key focus on this long-term thing is around risk management. So identifying what are those project types, where is that uncertainty coming from, technical readiness, supply chain permitting delays, to make sure that you're preparing for that and adjusting your plans for those long-term goals. Now, short, medium, and long term might mean different things to different organizations, and the timing of these efforts may have more to do with your CapEx plans or product life cycles than like a specific number of years. So, medium term might be it might not be 5 to 8 years. It might be when this production line is going to be revamped or when this expansion is going to be happening. So, it's important to think of it in those terms. So this next section, what we want to talk about is what is standing in the way or pushing you forward. So what are those constraints that are holding back electrification of your facilities, or those enablers that might help it? And on this side, even when the technology is viable, electrification projects can fail without readiness in some of these other areas. So these capture some of those common barriers: electrical infrastructure, so limited transformer capacity or electrical service from the utility, inadequate distribution within the facility can be a challenge. When you're looking at your processes or your operations, there might be downtime limitations for equipment changeover, distances across the facility between heat source and loads. I heard of one example where we're like, hey, we're in a facility and we're heating here and we're cooling here, and it makes so much sense to put a heat pump in instead of a boiler and chiller to just move that heat around, except heating happens over here and cooling happens on the opposite side of my facility. And that just makes the project not feasible. So looking at those process limitations, if a heat source is tightly integrated with other process steps, so you can't really change how heating is done without changing the entire process, that can really hold back some projects. Looking at different control systems, legacy systems might be incompatible with newer electric equipment. There might not be capacity for advanced sequencing, demand response, some of these new approaches that can mitigate some of those operational costs when it comes to utilities. There's always the economic and financial, so that spark gap, high capital costs. Companies might have short payback thresholds or a lack of an internal carbon price to make the case for some of these projects. On the organizational cultural front, operator familiarity with combustion systems is a strong motivator to not change things because they're not familiar with the new electric systems. There's also perceived risk of changing established processes. Sometimes it's not perceived. There are real risks in this, as Alan pointed out of it. Sometimes a lot of research has to go into it to figure out what those are. And then there's also external factors, policy, things like utility interconnection timelines, process approvals, available incentives, rate structures, government regulatory environment that has some uncertainty. All of these things are things that can hold you back and hold your projects back. So we're going to go back to the Menti question now. If you still have it open, you can go back to that now or follow the instructions at the top of the screen or the link that Evan just dropped in the chat. And I'd like to hear about what do you see as the biggest constraints in your facility as a barrier to electrification? So what are those things that are some of the big factors holding work in your organization or your facility back? All right. Costs coming up, the technology. Right, executives leadership, right? If there's not strong support there, that can really hold back progress. And I'm curious too, when you're answering this question, I think those external ones are definitely big issues, the price parity, those costs, the technology. But I think it's also useful to think about what are the internal factors as well. Are there internal constraints that might be holding these projects back, irregardless of those external constraints that are also happening? I see comments on price parity with natural gas. Yeah. Right. Staffing as well. The infrastructure. Okay. So these are great. On page 13 in the participant workbook, there is a checklist of potential constraints that you can refer to sort of think this through, and it can be really useful to help assess your facility's readiness. Again, kind of independent of those external drivers, which are very important, but the checklist can help look at, what are the constraints within my facility, and it can be really useful to do that self-assessment, highlight the ones that apply to you, because even if we end up with a situation like say tomorrow we had rate changes or new technologies were available, there may still be some of these internal barriers. So while we're waiting for those external factors to change, it can still be really useful to look at, okay, what are the internal barriers that you can start addressing or start trying to remove so that when those external barriers change, you can move quickly and you're ready to move. On the other side, there's constraints that can hold projects back, but there's also enablers that organizations can have, conditions, resources that will make electrification easier, faster, and more cost effective. And recognizing these can help you prioritize opportunities that are ready to move forward or are ready to move forward when those external drivers change to a point where it is feasible. So a big one is having that ample electrical capacity. So your existing service has headroom for new electric loads. If your utility has a fast track process for capacity upgrades, so making sure you understand what that is, what is available can be very helpful. Clean, low cost grid. Ontario is pretty clean, not as clean as BC, Quebec, Manitoba, but still very clean relative to many jurisdictions. But having those competitive rates, time of use can be very helpful in driving projects forward. The other thing is planned capital projects. In terms of, is there major equipment that's due for replacement or end of life, or facility expansion or reconfiguration that's already planned? These are great opportunities to piggyback and add incremental costs that can make a big difference in facilitating electrification rather than, a tear out retrofit of an existing process that is still working fine. So looking for those is a great opportunity to take advantage of that. Alan notes that shift in focus from cost savings to emissions reductions as long as the investment thresholds can be met. Yeah, so aligning those priorities is very important. Having that external incentives, funding available, new programs come and go all the time. So it's really important to be ready for those and that proven technology fit. So understanding what is the proven technology, particularly like some organizations just by their nature are more risk averse or risk welcoming. So some organizations are like, we're going to try this new technology, this new approach, and see if it works. And others do not want to do that. So I think understanding what your organization, what your facility is like, and if it is more risk averse of like, okay, so how are we going to address that and make sure that we find applications where it's proven, that's acceptable, that are low risk applications. So on here, we're going to go to the next one in terms of what are some enablers that you might be able to leverage at your facility. And on page 14, we have another checklist, and this one of potential enablers. So you can highlight those, use those for reference on there. And if you want to share on the Menti here, what are some enablers that are present in your organization, in your facility where you are, that might help electrification? Even if there are still barriers today, these are things that might help facilitate it, either short-term or even in longer-term ones that you could focus on. All right, I see legislation up there. There's lots of different legislation. I feel that in the last while, some of it is helpful and some of it is not, but knowing that legislation can be very useful. And like there's Ontario, there's Canada, there's international, as I mentioned, for some organizations, depending on where your markets are, the European Union border adjustment mechanisms have gotten a lot of attention in sort of driving thoughts and planning around electrification for some organizations. And I think some of that might, there's potential for that to grow as well. Like Canadian Infrastructure Bank, right? Using that as a resource, leveraging that. Leveraging renewables, in particular, was mentioned earlier by Karim that renewables can help make the case if you're in like a high cost of electricity jurisdiction. Having on-site renewables does come with other challenges, but it does help with that. Carbon tax definitely helps. Innovation, both that innovation happening in an organization that's open to innovation can be a really big enabler. Those utility incentives, yeah, save on energy, Enbridge play a very important role and are doing some really great work in providing some of those incentives. All right. So I think it is a lot of times I think we sort of focus on the challenges and the barriers, and it is important to still remember that there are things that can help in this area and focus on strengthening those within our organizations. Now, all this setup is in place because the last thing we want to talk about is, how do you change these insights about your organization, about what technologies are available, about your own processes. How do you change that into action and build a strategy for electrification through that short, medium, and long term? And one of the things I really want to stress in this is the role that uncertainty plays in this planning. So, first of all, uncertainty is inevitable. And I've seen some organizations try to like eliminate the uncertainty with studies or getting frozen by it. And it's really important to understand that it's just part of the process. There's technology gaps, policies are going to shift. There's market volatility for fossil fuels, for other things. A lot of this is normal in just, long-term industrial planning in general, but I think especially for electrification plans. These plans have to account for uncertainty in what's going to be happening. And it's important to manage that uncertainty and not try to avoid it. So instead of waiting for perfect clarity or perfect situations, use that adaptive planning, staged investments, pilot projects to move forward with what is possible now and remaining flexible. Part of that can be through scenario thinking, so developing multiple pathways. And this can be really useful in terms of managing uncertainty, because we don't know if this happens in the future, maybe we go this path. If this happens, maybe we go this path. So having those scenarios laid out is a really good way to help manage that uncertainty and bring some clarity and comfort to it. And also making sure to really stress that risk of inaction. So delaying action without a plan, it can lock in that fossil fuel infrastructure. You can make changes to your facility that are hard to retrofit in the future when it becomes necessary or when it becomes needed. So that can raise future compliance costs, can reduce competitiveness. So there is a significant risk to not doing anything and not planning for this. And that's really important to balance that in the discussion. So how do we go about doing this in practice? So we're going to look at 5 steps for you to kind of work through. And the first is starting with what can be done now. So identifying those low risk, high impact opportunities, those quick wins that do work with current budgets, operating costs, that you can bundle with other energy, ESG initiatives, organizational priorities, where you can leverage those co-benefits. So where those operating costs increases from the utility, from the fuel shift, are offset by other benefits, like maintenance reductions, process controls, safety, efficiency, quality, throughput, all of that kind of stuff. So start with what can be done now, what makes sense now, looking at that whole picture that we talked about earlier. Then you really need to identify where are those knowledge or technology gaps. Because we want to manage that uncertainty, we need to know where that uncertainty is coming from. So identifying those processes that are or will be suitable for electrification, just not today. And determining what is holding it back. Is it a technology maturity issue? Either the technology is not commercially available, or it is, but it's not as proven as you'd like it to be. Is there a lack of internal expertise or comfort with it? Is there product process validation requirements? What is causing that gap to be there? And then part of your strategy is planning to address that. So we need to do research, we need to do pilots or vendor trials or site-specific case studies, or do we just need to sort of keep our eye on what's happening, what other organizations are doing, what's available in the market, but having a plan to do that regularly and have a bit of a system around that. Because when you're doing that, then you can start building in gates and triggers into your strategy. So connecting those electrification opportunities to internal things like your capital asset timelines. So, if equipment's nearing end of life, you need a decision. If there's going to be a facility expansion or renovation, you have scheduled CapEx planning windows. Those are important milestones to be aware of because you need to be involved in those earlier, and probably earlier than you think in that process, to make sure that you're considering electrification. If it does make sense in that work, in that new expansion, in that new product line, in that equipment replacement, does electrification make sense now? Getting in early because there might be design or infrastructure changes that are required that could extend the planning period. Or if it's not feasible to integrate that into plan right now, how can those plans be adjusted or modified so that even if it's not electrifying, it's not creating a barrier to future electrification? You can also define triggers based on external factors. So, this makes sense, but only if there's an incentive for this, or only if that spark gap drops below a 3, or if carbon pricing comes back in. We have these. We know these make sense under those conditions, so that we can keep an eye on those, and know that when those conditions are met, it then triggers action. So that can be really useful. And then setting up those structured decision-making frameworks, go, no go, to sort of take account for these and make sure that you are updating your information regularly. It's also really important to communicate with your utility. All that talk about, what capacity is available, what is the lead times if you need a capacity upgrade, if you're planning that, what needs to be accounted for. All of that needs to be done early. So building in that into your strategy schedule with these decision gates and triggers is incredibly important. The next thing is design for that flexibility, avoid lock-ins. So I mentioned as part of those CapEx plans, you want to be involved early, and can you influence modular hybrid systems that can evolve over time and incorporate electrification when it does make sense, upgrading those electrical panels, designing pipe chases, ducting spaces to accommodate future equipment that you think you might need, and avoiding those really long life fossil fuel and investments that are going to lock you in and stick with it, unless there is that flexibility. And lastly, the importance of integrating this strategy with your broader business planning. So your electrification plans that you're working on, it needs to align with your organization's broader capital plans, ESG plans, facility life cycle assessments. One of the things that I find really useful in this, I think we've done a workshop before on objectives and key results. And that's a really useful way to integrate with broader business planning, because I know there's lots of situations where it's sort of like, oh yeah, we have a net zero goal, or we're going to reduce our GHG emissions by 70%, and that's coming top down from leadership. But they're not really listening when you say it's like, okay, well, that means we need to make this investment, and we need to make this investment. And those are still kind of following the old situation of projects and not necessarily getting the support. And using an objectives and key results framework says, like, if our objective is net zero by 2040, by 2050, then here are the key results that have to happen to achieve that. All new production lines need to be fully electrified. Existing process lines need to have plans in place to electrify by a certain date. All new buildings need to have adequate electrical infrastructure, things like that. Like, if these key results aren't met, we're not going to hit our objective. And framing it in that way can be really helpful in communicating internally the importance of some of these steps and some of these plans within your strategy to meet those organizational goals. Because it becomes very clear of like, well, you set that goal, we have to do this in some way in order to achieve that. So that communication is a very important part of that. So we've gotten to another fun part of the day. So this breakout room is going to be a bit longer. We're going to put you back into the same groups. And what I want you to talk about in this group is thinking about, those processes that you have in your facility. What do you think could be electrified in the next few years? Like, what are those short-term things that do make sense now that you could move on? And for those ones that don't make sense now but are a bit longer, what are those key decision points or triggers that you need to plan for? And what might you do to avoid locking in GHG emissions while you're waiting for that to make sense, for those longer term solutions to get in place? All right. So Evan's preparing those rooms. We're going to send you out in a minute. Is there anything I can clarify about this discussion before I send you off? Just raise a hand if you want. Also, sometimes Teams is a little finicky with this, so if you have any issues, you can type in chat for assistance. One of us will come into the room to try to troubleshoot it, or yeah, just let us know if there are any issues with that. All right, so Evan's going to launch the rooms now, and you'll have about 15 minutes in there with a countdown timer in the top corner. We'll see you back after that. Welcome back. Hopefully you had some good discussions around, what are near-term plans for electrification and what are you doing in the near term to help prepare or facilitate those longer-term electrification plans. One of the things about being the host is I don't get to hear those conversations in all those breakout rooms. So I'd really love to, if some of you could share some of what is discussed in those rooms. Like what did some of those near-term plans look like, and what did some of those actions to prepare for the longer term look like? Who'd like to share what was discussed in your breakout? Olga.
Yes, sorry. I had a small room, and I was lucky to talk to, say, federal government folks. I might be mistaken, but from NRCan, where they plan for and research on our industry electrification. So feedback from them was that right now focus from on industry goes to heating electrification, because we have lots of opportunities there with the air source heat pumps, which I pointed out. I would want to see, honestly, more not on air source heat pumps, but on geo-exchange, because air source heat pump, it's a great opportunity you can do quickly, but it doesn't have any payback. If you go to geo-exchange, it has payback, and for condos, say, it will have some folks told me even 7 years, 7 to 15 years right now, depends on how well you're contracted and how well project goes. But also there are lots of opportunities for Quebec and BC provinces, because they have lots of industry, and they have lots of enough clean energy, say Quebec especially. So on my side, unfortunately, I'm not industrial, not right now in industrial sphere. I'm in commercial real estate. So I'm really hoping for in the future go with geo-exchange, honestly.
Yeah, and we have seen. I haven't seen that in industrial applications, but I know U of T has a big geo-exchange heat pump project that they're doing there as well. So I think there's good opportunities there. From any other breakout rooms, what were some of the near-term focus opportunities, or what's being done to plan for those longer-term changes? What about Andrew or David? I'll call on you here. What was sort of discussed in your breakout rooms? We've got a bit of a shy group. That's okay. Hopefully there was some good discussion in your groups. If you want to share some of those key points, I still really would love to hear about those discussions. If you want to put those in the chat for the rest of the group to see as well, some of those key points or that came up in your discussions, that would be really helpful. The last thing, we do have some announcements at the end of this, but one thing I want you to do is also think about coming out of this discussion, what are you doing in the next few weeks to start that planning pathway? Is there anything different that you're doing coming out of this workshop, of some of the case studies, experiences or some of those tips around how to manage the uncertainty in the situations that we're in now to still achieve those long-term plans. What are you going to be doing in the near future, in the next few weeks, to start moving in that direction? If you can put that into the chat as well before you leave, that would be really great. We have a couple of announcements coming up. The Save on Energy 2025 Energy Management Excellence Awards are coming up September 17th at the International Center. They are sold out, so hopefully you have registered already, that you have your tickets for it. I look forward to seeing you there. It's always a great opportunity, and even if you don't, there'll be opportunities through Save on Energy to still hear about the winners, their experiences, what they've done, some of the great work that they're doing as well. So keep an eye out for that. I also want to announce if you haven't heard it yet, Save on Energy released a podcast this spring called the Energy Manager's Playbook, where it's conversations with energy managers talking about challenges they face in their organizations, on their role, how they overcome them. A really excellent resource to hear firsthand about some of the tips and tricks and advice that energy managers have to overcome some of these big challenges that are in your organizations. So please check that out. You can find it wherever you listen to podcasts, Spotify, Apple Music, etc. There's also a page about it on the Save on Energy website. And lastly, or sorry, not quite lastly, if you haven't joined the energy management community, if you are an energy manager or someone working in an organization to reduce energy consumption, reduce emissions, you can join the energy management community, get access to the energy management learning platform that has online courses, resources, discussion forum, free expert support, invitation to virtual discussion groups as well. All of this provided free of charge through Save on Energy. All you have to do is fill out the registration form using the QR code, or Evan will drop the link for that into the chat. And lastly, there is other support tools, resources available through Save on Energy. Evan dropped a bunch of links for those into the chat, including one big one is there's virtual one-on-one coaching. So post-webinar support. So if there was anything we talked about today that you want some additional help with, or have questions about, or want to learn more about, or for more resources, you can fill out that intake form to get access to some free one-on-one coaching and support following on any of the topics we discussed today. Also, in your participant workbook, at the end of it, there is a list of different resources to case studies, examples, resources on industrial electrification, so please check that out as well. And thank you all for taking the time to join today. Hopefully there was some good discussion in your breakout rooms and you had some useful information to come away with. So thanks again. Have a great rest of your week, and we'll see you at the next workshop.